It is an ongoing project, and the name of project is DoraCode. So DoraCode is an online code review platform which is built to organize the review process in industry, making it more structured, uh, you can say documented, more fast, and more efficient. uh, right now what happens that code review is often a slow process, and there is no structured way of reviewing a specific code. For example, if a person is reviewing a authentication code, then he review it on the basis of experiences had. So there are no structured points that he should be looking in a backend code or in a while implementing a feature or process, something like that. So through DoraCode, we are trying to solve this particular problem. We are trying to make code reviews faster, efficient, more structured, documented, and convenient. So DoraCode users signing through using their GitHub accounts. They basically create teams or can join existing ones, and create projects inside a team and can invite other teams to collaborate on those projects. Team constitute of different members, like there are leaders which can invite peoples to join a team, can remove peoples, like users can promote users to up in the hierarchy, can devote users, and then there comes members, regular members of the team. Members including team leader can start a review session, can comment during a review session, view review session history, select a review session template, and lots of other features that DoraCode provide. And then there comes viewer. Viewers are the stakeholder that don't have direct involvement in the development flow. They are just to understand what's happening, or basically if there is something like they need to overview. So those are the viewers that don't have direct involvement into the development process. So thus for such role in the team hierarchy, the only permission that given to them is to join they can join a review session, they can comment while a review session, they can view the review session histories, and resolve a comment, and lots of other features that are restricted to them only. So, uh, in DoraCode, there are a lot of architectural decisions that I have made, and I want to let you through them via a Notion doc that I have maintained throughout building the DoraCode. So, let me uh, open it. So, it's taking a time to load the initial content. Okay, so this is the schema architecture of DoraCode. So basically, there are some enums, and then there are users. These are the fields of users, and then auth token, refresh token, then teams, then notification, repos, project, in team invitation, user in team, and per project relationship table, session review session table, review session participant relation table, and then review file table, user integration table, comment table, integration ticket table. So this is the basic architecture of DoraCode. And one thing I forgot to tell about DoraCode is that it has AI into it. Right now, we will integrate AI into it so that code review can be faster. And also, at the end of every code review, there will be an AI generated summary, and their user can integrate third party management apps such as Trello. So whenever you want, you comment on a file during a code review, and you want a Trello ticket to be created to your corresponding dashboard, project dashboard, you just have to click on create a Trello ticket, and that will be handled and behind the scene for you, and you don't have to like sync all the things across different platform manually. The Dora code will do it for you. And it's have AI, it will have third-party integration and templates, or and yeah, that's it. And then there we can now see the architecture, file and folder architecture of DoraCode. So first of all, before going to it, I want to discuss the tech stack that I have used for DoraCode. So for DoraCode, I have used React and Redux in the front end, Node.js, Express.js in the back end, Prisma as the ORM, and PostgreSQL as the database, and REST APIs. And so it is so this is the files and folder structure. So this is the Prisma folder that contains the schema of the Dora code. Then there comes file config folder. It contains files such as nv.ts. So it's basically the validation for the environment variables. Then there comes passport.ts. It basically holds the GitHub strategy. It basically how the user will get authenticated using GitHub. The logic beside in this file. So Prisma.ts, this is the client, Prisma client that we gonna use throughout our project to communicate to our database. And then there comes the live folder. Live folder have app event.ts and async handler.ts. So app event.ts I will tell you later about it. Async handler.ts is basically a error handler, basically wrapper functions that wrap your controllers, and whenever error occur, they catch it and hand over it to the error handler. This is which is defined in the middleware. So other then there are email. So basically like whenever a session starts, whenever a session is scheduled, or you want to invite someone to your team, or you want to like send collaboration requests to some team, then you want to send email to them as well besides the in-app notification. So for such cases, we have defined email services and email templates for different use cases. And then there comes middleware. So we have authentication middleware, authorization middleware, and one more middleware that is not present over here. Let me show you. So here it is. So we have attached team context middleware. So basically we have since there are different in a project, there can be different users that are working on the project with different roles. Like there can be a there will be a primary team and collaborating teams, multiple collaborating teams, and each team will have different sets of permissions. And within the team, those permission will be divided separately to every user. Like if someone is a leader, then he will have different permissions. So such case, what we need to track, and also our same user can be in different teams. So in such case, we need to track the current active context of the user, and for that case, we extract the current active context of the user from the API itself and attach it to the request body, and in the authorized middleware we using that team context verify whether that this person is allowed to perform the requested operation or not. And so this was it, and there comes module section. So basically, there is authentication module and notification module. So for notification, we have used event-driven notification architecture. So what's it is about? Basically, the resource services that hold the business logic call triggers, or you can say fire events. Basically, for example, if our session is about to start, then a session dot start event will be fired, and there will be a central listener for those events. Let's say notification listener, which will be listening for those events, and it will call dispatcher. Dispatcher is the you can say component which has all the notification strategies registered to it, and it will call all the compatible strategies for the particular file event. And then there comes team modules, team invitation modules. There are a lot of modules. So basically, here you can see inside module you have collaboration, notification, project, repo session, team meeting, invitation. Okay, just click now. Uh, this is the authentication. Now I want to talk about the authentication. So basically for authentication, I have used JWT apart from not authentication. Basically authentication, I have used GitHub and password. And for the login and login sessions, to maintain the login session, I have used JWT. And in JWT, basically refresh token and access token. So basically, refresh token are those which resist long, like around 7 days, and refresh access token which needs to be needs to be recreated or regenerated in every 15 minutes. And then this is a particular learning that I drew from DoraCode, which is about parallelism and reducing the latency of your API calls. And basically, instead of sequentially calling APIs which are independent and fetching data, just wrap them inside promise.all or promise.all settle, so that they can be run in parallel and can reduce the latency of your system. And this is the diagrammatic flow of notification system. Here you can see services calling, services firing different events, emitting different events, and those events are being listened by a central notification listener, then which is in turn calling notification dispatcher, and notification dispatcher is checking which strategy is compatible with the given event and call those strategies. And this so basically, as I told you that there can be uh, uh, in a project there can be primary team and secondary team. So primary team can have reader, member, viewer, and similarly for secondary teams there can be leader, members, and viewers. So every of the user will have according to the current context. Like if the same user can be in different teams, like he can be in the primary team or as a leader, and in the secondary team as a member. So such cases we will track the current context, and according to the current context, we will define who the current user is. If is he a primary team leader, then accordingly we will decide which permission do he has. And I has defined a permission method for that. You can see like primary leader or primary teams leader have almost all of the like actions allowed to them but only the one that is deep collaboration, and that is something related to the collaborating teams and not the primary teams. And there further I have divided my project into several parts. So basically, there are up to fragment 4 that has been implemented, and fragment 5 is currently in implementation, and there are 1, 2, 3, 4, 5 more fragments to be implemented yet, and those fragment just contains the future goals of the DoraCode, that is features that I talked about, like AI integration, Trello integration, and review session templates, and all that things. This is one another learning that I drew from DoraCode. Basically, when the switch keys grow in size, then instead of switch keys, use builder map, which are more type safe and easier to use and easy to scale, and ensure type safety, and reduce the no, like what you say, possibility of errors. And so this is the authorization flow that I talked initially, like how team context is extracted from the API. Like first the user is authenticated, then user team context is extracted from its URL according to the resource. Like if it is a team resource, like if the API is if API belongs to team resource, or API belongs to project resource, session resource, or repository resource, accordingly the team context get extracted from the API endpoint and is attached to the you say your request body. And if there is an error in between, then accordingly the error response is sent, like in many of the cases 403 forbidden responses sent back. And if it's the team context is found, then it is got attached to the request body and is sent to the authorized middleware, where it check whether the user has the permission to do such task. And then finally controllers run, and the service layer request goes to service layer, and then finally we call in the success response. So this is basically a visual representation of permission metrics. And then these are the API endpoints which are defined for the DoraCode, and which are, you can say, divided according to the modules that we gonna have in DoraCode. And this is the testing status right now. We have tested 4 modules end to end using Postman, and basically in Postman we write this automatic scripts, so to test them into it. And there are some challenges while designing DoraCode initially, like how to if the PR got updated, like someone push new commit to a PR, then the review session that is currently being operated for the PR, how will those changes will be accommodated, like the PR got the revision code got updated or not. So for that we use head commit, like we log the head commit, and that's a bit complex to explain in a short time. So we will move forward, and there are some issues like must not trust live branch tip after session start. That is what I told you earlier, that once the session is start, we should log the head commit, and we should fetch the code using that head commit, and not the tip of the branch. And there comes compare response can be truncated. So the response can be truncated, like if we are fetching the code from the GitHub APIs, and if the for large repositories the code can be truncated. So for this reason, this was one of the challenge I have to solve, like instead of fetching all the data all once, I have to recursively call data for files and go deeper into the files and folder structures. So in order to like prevent truncation, and then file review risk condition on first load, file status like file contradiction, and session close should have soft and hard mode and all that stuff. So this thing is like comment and again something related to. So this is the collaboration flow, bit complex to again explain this short video. And then this is the testing, like how I tested um, uh, uh, features is being shown here. And then this is promise dot all and promise dot all schedule versus transaction, something I again learned while building DoraCode. Then there is finite state machine and the concurrency control, which is a very beautiful thing that I got to know about while building DoraCode. So that's all in the DoraCode. Thank you. Okay, before ending, I would also like to show the repository that I have maintained for DoraCode. And let's see, here it is. Okay, so there are the commits, and there is the code for the DoraCode. Thank you.